Hi Shannon. So I'm going to be making the videos for each of the classes that we've had this week, and I'll post each video on the Google Classroom post that I already made for the classes this week. So for this first part, there's a PowerPoint that I attached on that post. The post for discrete random variables, probability distribution function of a discrete random variable. I think I posted it on Monday. So you can go and check the PowerPoint and then use the PowerPoint to fill out these blanks. One key idea from that PowerPoint is each of the probabilities is between 0 and 1 for a probability distribution function. So probability distribution function just helps us to see what the probability is for each single trial in the distribution. That's why it's called probability distribution function. It's like a frequency table for probabilities only. That's why it's called a probability distribution function. Don't let the wording confuse you, the PDF, don't let that confuse you. It's simply a table of probabilities. A table that's showing you the event or the random variable, which is called x, and the probability for each trial of that random variable. So if it's 0, that's the probability. If it's 1, that's the probability. Now, there are some things that are true about probability distribution functions, or things that are properties of PDFs. One of them is that each of the probabilities is between 0 and 1, yes, and 1 is included. The other one is that the sum of the probabilities, the sum of all the probabilities must equal to 1. So, for example, in this table here, if I add up all of these probabilities, they should give me 1. If they give me 1, then it's a PDF. If they don't give me 1, it's not a PDF. So I'm just going to do a couple of examples for you, and then you can go and try the rest of the examples. Hospital research is interested in the number of times the average post-op patient will ring the nurse during a 12-hour shift. Okay, for a random sample of 50 students, so that's your total number of patients, the following information was obtained. X is the number of times the patient rings the nurse during a 12-hour shift. So the patient can ring the nurse 0 times, once, twice, 3 times, 4 times, or 5 times. And the probability for each of these times happening is given in the table here. So for example, 16 out of 50 is the probability that a patient rings the nurse 2 times, right, in a 12-hour shift. Is that okay? And remember, it's only 50 patients that were sampled. So for this exercise, x equals 0, 1, 2, 3, 4. This is the random variable because these are the times, this is the thing that's changing, the times that a patient calls the nurse. Those are the things that are changing, so that's your random variable. Px is the probability that x takes on the value x. I mean that capital X takes on the value x. That's just telling you that P of x is the probability of x, right? As straightforward as that. So they're asking you, why is this a discrete probability distribution function? Give 2 reasons. First of all, if you look at each of these probabilities, none of them is bigger than 1, right? None of them is bigger than 1. So that's one of your answer, that each of the probability, right? Each probability is between 0 and 1 inclusive. The second reason you can give, and this is a task that I would like you to do, add up all of these probabilities, right? Add up all of them. 8 out of 50, 16 out of 50, 14 out of 50, 6 out of 50, and 2 out of 50. Add up all of those probabilities and see if they give you 1, right? If they give you 1, that's your second reason. Remember, your first reason is this one here, because you can see from the table that each of these probabilities is between 0 and 1. Let's look at this second one. So it's the second, I think it's the same example, right? Why is this a discrete probability distribution function? Oh, I don't know why I wrote this twice, but okay. What's the probability that the patient calls the nurse at least 3 times? Maybe this is the reason I added this. So probability of at least 3 times means what's the probability that the patient calls the nurse 3 or more times, right? So 3 or more. Let's see, 3 or more, we have 3 times, we have 4 times, right? We have 3 times and we have 4 times, and this table wasn't completed, but we have 3 times, we have 4 times, and we have 5 times because this is the same question. So the probability that this person calls the patient at least 3 times is, you're going to add the probability that the patient calls the nurse 3 times plus probability that they call them 4 times plus probability that they call them 5 times, right? So that will give you the probability of at least 3 times, because you're looking at this table and I'm using this table because this question is just the same as that question. At least 3 times is 3, 4, or 5 times. If you had said at least 2 times, that will be 2, 3, or 4, or 5 times. Another example. Suppose Nancy has 3 classes a week. She attends the 3 classes 3 days a week, 80% of the time, 2 days a week, 15% of the time, and 1 day 4%. No days 1% of the time. Suppose that the week is randomly selected. Let X be the number of days Nancy attends class per week. What values does X take on? So remember, she attends class 3 days a week, and it's telling you that X is the number of days Nancy attends class per week. So the values that X can take on can be 0 because she can go to class 0 days a week, can be 1 because she can go to class 1 day a week, 2 because same reason, and 3 because the maximum is 3 days a week, and it's asking you what values it could take on. So it could be 0, it could be 1, it could be 2 or 3. Suppose a week is randomly chosen. Calculate the probability distribution. Construct a PDF table, and the table should have 2 columns labeled X and P of X. What does the P of X column equal to? So for that part B, you're just going to draw a table. Let me draw a table here. Find somebody to fit it. You're going to draw a table that has X and P of X, right? X are the values that the number of days a week that she could go to class. So that can be 0, that can be 1, can be 2 or 3, right? And this question told you that she attends class 3 days a week. 3 days a week is 80% of the time. So the probability for 3 days a week is 0.8. 2 days a week is 15% of the time. So this is 0.15. 1 day a week is 0.04, sorry. And 0 days, no days, is 1%, 0.01. So that's your probability distribution table. Jeremy has basketball practice. Construct a PDF table. You can do this one, right? A baker is deciding how many batches of muffins to make and sell in his bakery. He wants to sell enough to make wants to make enough to sell everyone enough sugar. Through observation, the baker has established a PDF, which is given by this table here. Define the random variable. The random variable is the number of batches of muffins to make, right? That's his random variable, because that's what is changing, the batches of muffins that he's making. That's what's changing, so that's his random variable X. What's the probability that the baker will sell more than 1 batch? So more than one means he can sell 2 or 3 or 4, right? So you just add these probabilities, 2, 3, and 4 for more than 1. Then you get the answer. Probability that they sell exactly 1 is equal to 0.15, because that's exactly 1. We said at least 3 batches, X greater or equal to 3. So that will be X greater or equal to 3. That will be 3 or 4, right? 3 or 4, which you just add the probability for 3 and the probability for 4. Airports. And lastly, on average, how many batches should the seller make? The average from PDF is given by finding the sum of all X values times the probability of X equals X. sum, you're going to multiply 1 times 0.15 plus 2 times 0.25